For the first assignment, you need to extend the hot dog stand model that we developed during the previous videos so that the stand is open from 9 a.m. until 9 p.m. So where previously in our lab or during the videos the stand was open from 9 to 3 and saw a lunch rush, I want you to add a late afternoon, a dinner rush, and late evening arrival processes also. So the first thing you need to do is to actually extend this arrival process to accommodate that dinner rush and late evening. And so I want you to use your personal knowledge of fast food restaurants, how they work, and your judgment to come up with a reasonable arrival process. Once you have the arrival process defined, then you need to implement this with our rate tables and then update the resource schedule to support the new arrival process, the dinner rush, and so on. Once you have the model developed, then develop an experiment, and in the experiment include responses for server utilization, and the average and maximum time that customers spend in the system, and the average and maximum number of customers in the system. The second assignment involves updating the model that we did in the very first video of the manufacturing system. Recall we had 5 servers and we had 3 different part types, and we developed a table structure to support part arrivals. The update that we want to do is to support orders for parts that arrive according to a given schedule, and there's a spreadsheet that provides the data. So let's have a look at that. And so here are our 2 tables that we already had in the model, the part type table, A, B, and C, and we used the priority and the product mix earlier. And then the sequence table gives the processing sequence for each parts. What functionality you need to add is supporting orders. And so we have a set of orders that for a given arrival time and a given part type. And your task is to implement this order process in the model so that instead of having random arrivals, we will have arrivals that occur according to the given time for the specified part. And also want you to assume that an order arrival, all order arrivals can deviate from their scheduled time by plus or minus 10 minutes, and this time should be uniformly distributed. Finally, I want you to create an experiment with responses for the average time that parts, all the part types together, spend in the system, and the number of parts completed when the simulation terminates. And of course, since we're reading the orders from the external data table, we would assume that the number of parts produced would be the same for every replication. However, the time and system might vary because the deviation that we have in the arrival time for orders.